Hello everyone, welcome to my channel. In this video I have this integral to work on. It's the integral of x to the power 4 plus 1 all over x to the power 6 plus 1 dx. Now looking very intimidating, but you'll see how we approach it. Taking this to our first page. So we have the integral of x to the power 4 plus 1. We're dividing this by x to the power 6 plus 1 dx. Now I want to remind you something here. It's called factorization of the sum of two cubes. So if you have a cubed plus b cubed, how we factorize this is as follows. You take the cube root of a cubed and b cubed, add them because there's a plus sign here, so it will be a plus b. In the second bracket, you take a multiplied by itself, which is a squared. You take a and b, multiply them, ab. Then check the sign here. If it's a plus sign here, you must have a minus sign here. If there's a minus sign here and there, you must have a plus sign here. And then finally take b multiplied by itself, you get b squared. This is how we factorize it. Now notice that x to the power 6 plus 1 is the sum of two cubes as well, because we have x to the power 2 all cubed plus 1 all cubed. And therefore we can apply that by saying that this is the same as x squared plus 1. Remember, a plus b, x squared plus 1. The other bracket, x squared times itself is x to the power 4. And then x squared times 1 is x squared. The sign here is plus, we must have a minus sign here. And then 1 times itself, the answer is 1. So this is what we're going to apply in the denominator here as follows. So this is the same as the integral of x to the power 4 plus 1 all over x squared, like I said, plus 1. The other bracket must contain x to the power 4 minus x squared plus 1. Factorization of the sum of two cubes. And then we have dx here. Like I explained here, you can clearly see that that's the approach. All right, now I'm going to perform a trick in the numerator there. The trick is as follows. Watch this very carefully. I'm looking at this expression here. In this expression, I have x squared, x power 4 plus 1 there, and I have x power 4 plus 1. So I am missing a term here, and it's that term in the numerator. So what I'm going to do is to introduce what we call the special zero. So I'm going to have x to the power 4 minus x squared plus 1. But remember, I have introduced the term minus x squared. To cancel it, I must have plus x squared there in the numerator. And you can see that's your special zero right there. And then we're dividing this by x squared plus 1 in one bracket. The other bracket must contain this expression, which is x power 4 minus x squared plus 1, and then we have dx. Fantastic. Now I'm going to use term-wise division here now. Looking at this part here in the center, splitting the numerator into that part and that part takes us to the next step, which is this step here, the integral of x to the power 4 minus x squared plus 1, and I'm dividing this by x squared plus 1 in one bracket, and then x power 4 minus x squared plus 1, another bracket, and let me use a square bracket here, plus, and then it will be that divided by the same expression. So I'm going to write it over here. So I'm saying now we have, in the numerator we have x squared, and we're dividing the whole of that by x squared plus 1, and then the other bracket must contain x to the power 4 minus x squared plus 1, and then we have to close the square bracket, and then we say dx. Right, now watch what I'm going to do. If I put this in brackets, you can clearly see that this cancels that. So taking this to page 2, on our next page, we have the following. We have the following now on our next page. As you can see, so on our next page we have the integral The first part is going to be, remember there's a 1 here. When you cancel this into itself, 1 into that 1. So in the numerator we have 1 all over x squared plus 1, the first part, and then we have plus this part here. We have x squared all over x squared plus 1 in one bracket. The other bracket must be x power 4 minus x squared plus 1, and then we have dx. Now notice something here. I can distribute dx and the integral in our next step. The integral of 1 all over x squared plus 1 dx, and then plus dx here, and then plus the integral of x squared all over. Now watch what I'm going to do. Remember where this comes from. Look at this expression here. This expression comes from that expression. So I'm going to need to go back there to x power 6 plus 1. And then I have dx. I can put dx in the numerator. It doesn't really matter. Right. Now, you will agree with me that this is just arctan or tan inverse. So this is tan inverse of x. That's the integral of this part. And then plus. Over here, I'm going to do a little trick again. Watch this. X squared all over x power 3. And I'm going to say squared plus 1 dx. Yes, use substitution now will come in. So now I'm going to let, on this part here, I'm going to let u be equal to x cubed. This expression there. And then differentiate u with respect to x. Du is equal to 3x squared dx. And if you look at this part here, we have x squared. And therefore I can create 3x squared here, and then I have to divide by 3. So this integral changes to tan inverse or arctan of x plus, watch this, 1 over 3 times the integral of 3x squared all over x cubed all squared plus 1 dx. Nice. Now 3x squared is introduced. You can see it there. In place of 3x squared, I'm going to have du. And then in place of x cubed, I'm going to have u. And then I carry on. Taking us to page 3 to just finish this off. Now, as you can see, we are basically saying that we still have tan inverse on the first part, or arctan of x. On the second part, I'm going to have 1 over 3 times the integral. If you like, 1 all over, rewriting that, x cubed all squared plus 1 times 3x squared dx. Why am I writing it like this? So you can see that 3x squared is actually du over here. As you can see, 3x squared equals du there. So now, therefore, I carry on as follows. Tan inverse or arctan of x plus 1 over 3 times the integral of 1 all over. This becomes u squared plus 1, and then I have du here. Fantastic. Again, you can agree with me that that's just arctan of u. This integral here is arctan of u. So I have tan inverse or arctan of x plus 1 over 3 arctan or tan inverse of u, and then I have to say plus c because we're dealing with an indefinite integral here. There are no limits of integration. But what is u? Let's revert to our original variable. U is equal to x cubed, as you can see. So now my final solution then to this integral is the following. Tan inverse of x plus 1 over 3 tan inverse or arctan of x cubed, and then plus c. So this is the final solution to this integral we have been working on in this video. Let me just remind you the integral we have been working on. It's this integral here. This integral, and our final solution is this one here. 2 tricks we've performed in this one. The first one is the special zero over here. The special zero, as you can see, these 2 terms will give you 0 there. That special zero. That's one trick. The second trick, obviously, as you can see in the denominator, factorization of the sum of 2 cubes. And that's what we've done. This is not so much a very serious trick here, but yeah. The arctan being involved here, and also use substitution. So you can call this an advanced case of use substitution as a technique of evaluating integrals. Tell me what you think about this integral. I'll be interested to hear from you. Right, see you in the next one.